Today's title of topic is Mining Conservations and Utilization of Natural Resources in Ancient India. Module 1 Introduction. Mining and metallurgy contributed a lot to India's development. India has been recognized as a country well endowed with various natural resources. Mining was practiced well in the land of India, and along with mining, metallurgy of various metals also developed. This chapter will cover mining history of most well-known metals like coal, diamond and gold. History and achievement of Indian metallurgy will also be discussed, and following topics will be covered. 1. Mining scenario in ancient India. Mining for mostly used minerals in India. History of metallurgy in India. Metallurgy of mostly used metals in ancient India. Module 2 Mining scenario in ancient India. Ancient Indian mines. Knowledge on the ancient Indian mines which were active during last 3 or more millennia. Mines of the ores and minerals of copper, gold, zinc, lead and silver which were distributed throughout Rajasthan, Haryana, Bihar, Bengal, Gujarat, Karnataka, Uttar Pradesh, Madhya Pradesh, etc. The technology adopted for digging, mining, transportation, processing on the spot, provisions given for aeration and lighting in mines, etc. Ancient Indian knowledge in metallurgy. The production and purification of metals, use of flux and slag, temperature attained technology for production and purification of metals like tin, copper, iron, silver, zinc, lead. An understanding of the chemical reactions accomplished like oxidation, reduction, slag formation, distillation of low boiling metals, etc. The fine technology used for the large scale production of bronze, brass, panchloha, bell metal, coin making metals and many alloys mentioned in chemistry books and also in the books like Chanakya's Arthashastra. Impressive metallic alloy preparation techniques mentioned in the Rasa books, Rasopnishad and Bhardwaja's writings. The metal ingots, sheets, plates, etc. of Indian origin excavated from other countries like Athens, Babylonia, Rome and Egypt. How the ancient people initiated the mining techniques. The process of mining the earth and finding the metals, minerals, etc. and again making the earth to return back to its original state consists of different steps. Generally, mining techniques can be broadly classified into 2 types. They are surface mining and underground mining. In prehistoric period, when the people had found metals like copper, iron on or close to the earth's surface, they used to manufacture some tools and weapons. The ancient known mine is the Lion Cave, which is in Swaziland. Ancient people used hammers, crude picks, etc. But they found it very difficult to find the metals of any other precious stones which were in too deep. So they slowly started to invent new ideas to make the work simple. Since there was no blasting method available in that period, they first used to keep fire on the hard rocks to make it soft. Then they used water to cool it up, and so they had broken those hard rocks easily. The slaves, prisoners of war, and the people who did crime were forced to work on the mining areas. And the kids were used to carry the ores from the underground mining area to the outer surface. Then the people who were weak to work underground were made to separate the rich and poor metals. In some countries, they used black powder to disclose ore veins and earth to loosen. Then as the development occurred, the people found a plenty of techniques to find the metals, minerals, and other precious stones. Some of the ancient mining techniques were: first, fire setting; second, hydraulic mining; third, reverse overshot water wheels. First, fire setting. Fire setting method was used to fracture the rock mass during the 5th millennia BC. In order to evacuate the consecutive fumes, aeration shafts were drilled, and elaborated timbering and rock transportation methods allowed the exploitation of much complex deposits and ore, such as chalcopyrite deposits and iron and copper sulfate. More recent archaeological examples are known from medieval Zawar Mochia in India. Fire setting is a method of traditional mining used since prehistoric times up to the Middle Ages. Fires were set against a rock face to heat the stone, which was then doused with liquid, causing the stone to fracture by thermal shock. Some experiments have suggested that the water or any other liquid did not have a noticeable effect on the rock, but rather helped the miners progress by quickly cooling down the area after the fire. This technique was best performed in open cast mines where the smoke and fumes could dissipate safely. The technique was very dangerous in underground workings without adequate ventilation. The method became redundant with the growth in use of explosives. Second, hydraulic mining. Hydraulic mining is a form of mining that uses high pressure jets of water to dislodge rock material or move sediments. In the placer mining of gold or tin, the resulting water sediment slurry is directed through sluice boxes to remove the gold. It is also used in mining kaolin and coal. Though essential in extracting gold-rich minerals, the widespread use of the process resulted in extensive environmental damage, such as increased flooding and erosion, and sediment blocking waterways and covering over farm fields. These problems led to its legal regulation. Hydraulic mining has since been used in various forms around the world. Third, reverse overshot water wheels. Frequently used in mines and probably elsewhere, such as agricultural drainage, the reverse overshot water wheel was a Roman innovation to help remove water from the lowest levels of underground workings. It is described by Vitruvius in his work De Architectura, published circa 25 BC. The remaining systems found in Roman mines by later mining operations show that they were used in sequences so as to lift water a considerable height. Module 3. Mining for mostly used minerals in India. Diamonds mining. India was the only major producer of diamonds until the discovery of diamonds in South Africa in 1866. Diamond was first found in India during the 4th century BC. India's diamonds were recognized by many people because of its big size and beauty. India's diamonds were mined in Golconda, Hindostan and Rawalkonda. The main diamond fields were in Golconda. These sites were mostly alluvial. Among all diamonds in India, diamonds of Golconda were the most recognized. Diamonds of Golconda include the Hope Diamond, Kohinoor Diamond, Orlov Diamond and Sank Diamond. Gold mining in India. India has long been mining gold, first from the placers and then to the oxidized and primary zones of a variety of deposits. Archaeological data and written records indeed indicate that India worked gold placers and the rich oxidized zones of ossiferous deposits. Large-scale gold mining started when the Mauryan colonization of the Deccan by the end of 4th century BC. Coal mining. The industry of coal mining in India started in 1774 by Messrs. Sumner and Heatley of East India Company in the Raniganj coal field along the western bank of river Damodar. From then on, the production of coal came to a sudden drop because of the lack of demand. However, after the start of Industrial Revolution, the introduction of the steam locomotive in 1853 again stimulated the commercial coal mining. Within a short span, production rose to an annual average of 1 million ton, and India could produce 6.12 million tons per year by 1900 and 18 million tons per year by 1920. The production got a sudden boost from the First World War, but went through a slump in the early 30s. The production reached a level of 29 million tons by 1942 and 30 million tons by 1946. Module 4. History of Metallurgy in India. Metals were mined and utilized in the past in the processes from the use of native metals to those metals which could be easily smelted from the ores and to those metals which were hard to be smelted. The common metals in antiquity were gold, silver, copper, iron, lead, tin and mercury. Indian metallurgists' achievements were indeed significant. Its heritage in metallurgy is a matter of pride for India for sure. Early developments until 2000 BC. Metallurgy in India started during the second millennium BC and continued in British rule as well, that is, from 1858 to 1947. Recent excavation by an archaeologist, Rakesh Tiwari, in Middle Ganga Valley manifest that iron metallurgy began as early as 1800 BC. Other archaeological sites like Malhar, Dadupur, Rajanala Katila and Lahora Deva in the state of Uttar Pradesh support this by providing iron implements from 1800 BC to 1200 BC. By the early 13th century BC, iron smelting was already used in India. In southern India, iron objects were found to be created from 11th century BC to 12th century BC. However, these developments were too early for important contact with northern Indian to take place. Early iron objects such as knives, arrowheads, spoons, bowls, etc., ranging from 600 BC to 200 BC were found in many sites. Bronze Age swords of copper were found to be created from 2300 BC. These swords consist of bronze, but more commonly copper. Many of these were discovered in Fatehgarh. These swords date back to the period between 1700 BC to 1400 BC, but they were more commonly used during the opening centuries of first millennium BC. In the beginning of first millennium BC, the iron metallurgy largely developed in India. Technological advancements and mastery of iron metallurgy was gained during these years of peace. The key to successful iron production in India lay in the development of air blast supplied by the push and pull bellows during the Mauryan Empire, that is from 322 BC to 185 BC, which was politically stable. Technology of metallurgy was advanced greatly in 300 BC. Southern India was producing the high quality steel by using the crucible skill. In this method, iron, charcoal and glass were mixed together in a crucible and heated until the iron melted and absorbed carbon. The first of this crucible steel was Wood's steel. Wood's steel, which originated in India before the Common Era, was exported to ancient Europe, China and Arab world. It became prominent in the Middle East, where it was soon known there as Damascus steel. Early Common Era to early modern era, that is 200 BC to 1757 BC. Indian blades made of Damascus steel was exported to Persia. Indian wood steel, which was exported to ancient Europe, China and the Arab world, came to be called as Damascus steel there from 3rd century to 17th century. Indian manufactured Damascus swords were obviously articles of exceptionally high value and at the very top of the metalsmith's art. Also during the reigns of Chandragupta II, that is from 375 to 413 AD, the world's first iron pillar, the Iron Pillar of Delhi, was created. It is regarded as the most important and great testimony of metallurgy in Indian subcontinent. The pillar, unlike the stone pillars of or lats of Ashoka, is made of iron, and the village is better known as the site where Delhi's Sultanate world built renowned Qutub Minar and mosque. A very interesting fact about the iron pillar is that it is rust proof. Recently, the mystery of this iron pillar was revealed. The high amount of phosphor in the iron, about 1% compared to today's usual 0.5%, formed a layer of mesamite which protected the iron pillar from rusting. Unlike modern people who use mainly limestone, the ancient Indians used charcoal during iron extractions. It is surprising that ancient Indians figured this out long time ago, but contemporary technique still deals with the rusty iron. During the imperial Chola dynasty, the statues of Nataraja and Vishnu were built in the 9th century. The casting involved the mixture of 5 metals: copper, zinc, tin, gold and silver. Indian metallurgy under Mughal Emperor Akbar flourished with excellent small firearms. Mughal handguns were stronger and more accurate than those of European countries. Srivastav and Alam commented about Indian coinage of the Mughal Empire during the reign of Akbar. Akbar reformed Mughal currency to make it one of the best known of its time. The new regime possessed a fully functioning tri-metal, that is silver, copper and gold currency, with an open minting system in which anyone willing to pay the minting charges could bring metal or old or foreign coin to the mint and have it struck. All monetary exchanges were, however, expressed in copper coins in Akbar's time. In the 17th century, following the silver influx from the New World, silver rupee with new fractional denominations replaced the copper coin as a common medium of circulation. Akbar's aim was to establish a uniform coinage throughout his empire. Some coins of the old regime and regional kingdoms also continued. Colonial British era to Republic of India, 1757 to 1947 AD. Foreign competition, absence of tariff barriers and lack of technological innovation hindered the development of mining and metallurgy in India during the colonial period. British were aware that metalworking played a considerable role in supporting indigenous power in the past through the production of firearms and ammunition. Therefore, British took a step to limit Indian metallurgy and mining to prevent future wars and rebellions. In Arms Act in 1878, British limited Indian access to firearms. Rajasthan, the region rich with metals, was considered by British as an important means that made Indian struggle so hard against superior British. So by the 19th century, once flourished mines of Rajasthan were mostly abandoned and miners became almost extinct. During the company period, local workforce of mine and metallurgy gradually eroded as military opponents were eliminated. As late as the rebellion of 1857, the mining of lead for ammunition at Ajmer was considered dangerous. Consequently, the mines in the region were mostly closed down by the British. Module 5. Metallurgy of mostly used metals in ancient India. India, has a rich cultural heritage to boast about. But what many would not know is that ancient India had several achievements in metallurgy too. History traces the origin of metallurgy in India to 1st millennium BC. In ancient Vedic text, there is sufficient mention of metals to support the fact that people of that era made use of metals in creating weapons, armor, ornaments, statues, pillars, artifacts, and, believe it or not, medicine. Iron. The iron pillar in Delhi is proof of advanced metallurgy in ancient India. The pillar weighs over 6 tons, is more than 7 meters tall, and is constructed on a single forge. Even in today's technologically advanced world, creating an iron pillar of this nature will be considered a marvel. But what is even more marvelous is the fact that the pillar has not rusted despite being 98% iron and over 1600 years old. This is because the ancient Indians used charcoal as a reducing agent to extract pure iron with low carbon from the ore. Studies reveal that the use of iron may have begun in India from about the late 2nd millennium BC, and iron smelting was well established during that era. Gold. While much of the gold in the past was imported from the Roman Empire, research shows that local supplies also formed a significant portion. The deepest ancient gold mine in the world was situated in Karnataka in India, with carbon dates from 1st millennium BC. Zinc. Ancient mining sites found in Rajasthan reveal the use of highly developed metallurgical technology for extraction of zinc in ancient India. It is also believed that the production of zinc during that era was very common, and there is evidence to suggest that zinc was first produced in India. Silver. The discovery of ancient coins made of silver suggests that the metal was well in use in ancient India. The Aravalli region in northwest India is supposed to have been producing silver from about the mid of 1st millennium BC onwards, ranking it among the few major ancient silver producing sites. Copper. Copper and its alloys were used to create copper-bronze artifacts in India during 2nd millennium BC. Bronze images of Buddha and Hindu deities found in Magadha and Varanasi are ample proof of the rich use of copper technology in ancient India. Metal therapy. Processed metals like mercury, gold, silver, lead, zinc, copper, etc. were used by Indian seers to treat different disease conditions in ancient India. The metals acted as therapeutic tools that the seers used with authority. Ancient Indian technology knowledge on the ancient Indian mines, which were active during last 3 or more millennia, mines of the ores and minerals of copper, gold, zinc, lead and silver, which were distributed throughout Rajasthan, Haryana, Bihar, Bengal, Gujarat, Karnataka, Uttar Pradesh, Madhya Pradesh, etc. The technology adopted for digging, mining, transportation, processing on the spot, provisions given for aeration and lighting in mines, etc. The production and purification of metals, use of flux and slag, temperature attained, technology for production and purification of metals like tin, copper, iron, silver, zinc, lead, an understanding of the chemical reactions accomplished like oxidation, reduction, slag formation, distillation of low boiling metals, etc. The fine technology used for the large scale production of bronze, brass, panchaloha, bell metal, coin making metals, many alloys mentioned in chemistry books and also in the books like Chanakya's Arthashastra, impressive metallic alloy preparation techniques mentioned in the Rasa books, Rasopanishad and the Bhardwaj writings, the metal ingot sheets, plates, etc. of Indian origin excavated from other countries like Athens, Babylonia, Rome and Egypt, iron making technology, production of pig iron, cast iron and wrought iron in ancient India, Delhi and Dhar iron pillar, forge welding lamination, paint coating for preventing rusting, making of swords, the Banaras and Kodumanal swords, carburization instruments used in agriculture and surgery, rust-free preservation techniques adopted for iron, wood, steel, large-scale production of iron alloys, export of iron to European and Middle East countries, etc. Ceramics, science and technology. The top quality ceramic vessels like glazed vessels, beads, bricks, etc. produced in Harappa, Mohenjo-daro, Lothal, Varanasi, Takshila, Kalibhangan, Hastinapur and many other North and South Indian archaeological sites. Variety of coloring material used for the ceramic vessels and decoration ceramic articles. Glass technology. Industrial and instrumental glass technology existed in India. Variety of multicolored glasses with different size, shape, appearance and capacity produced in India. The glass beads, ornaments, plates, vessels made using variety of inorganic coloring materials like the oxides, carbonates, sulfates, phosphates, etc. of chromium, lead, copper, iron, nickel, calcium and sodium. The non-metallic compounds used as coloring materials. Technology introducing the golden and silver leaf plates in glass. Mining of various metals and use of various metals in antiquity are very much linked to the history of the Indian civilization. As historical evidences prove, India indeed was a nation which has superior techniques of metallurgy and mining than other countries. Many of the modern Indian metallurgic methods came from ancient practices before the Industrial Revolution. Monuments of metallurgy such as Iron Pillar of New Delhi demonstrate superiority of India's metallurgic technologies. Also, Indian mining of metals such as coal well served India's economy with many work opportunities and economic gains. Coal mining especially is well recognized even nowadays. Even though mining and metallurgy was disturbed by British during India's colonial period, they indeed were in the core of activities of the Indian economy. Thank you.